All right, let's get right into it. Most organizations evaluate cloud providers based on pricing, compute performance, or maybe just whoever has the coolest new services. But today, in this explainer, we're going to look at something far more critical. We're looking at what actually happens when the cloud itself breaks. Welcome to a deep dive into tenant-level resiliency, where we are putting two absolute giants head-to-head, Microsoft Azure and Amazon Web Services.
So ask yourself, can your organization actually survive if an entire cloud region goes down? If you're a CIO, a CISO, or a CTO tuning in, look, this is no longer just some theoretical tabletop exercise for your engineering team. We really need to shift our perspective away from basic server uptime and start focusing entirely on business continuity and managing blast radiuses when things inevitably go wrong.
To figure out the ultimate metric of survival, here's our roadmap. We're going to define resiliency, compare identity defense, control plane isolation, infrastructure and storage, and cyber recovery, and then wrap up with a complete decision framework.
Okay, Section 1, Defining Resiliency. Let's look beneath the surface of basic cloud availability.
So what exactly is tenant-level resiliency? Basically, it's the ability of a cloud provider to ensure you, the individual customer, remain operational, secure, and recoverable during infrastructure failures, cyber attacks, or control plane outages. This goes way, way beyond just making sure your servers are running. It touches heavily on the shared responsibility model. It really forces us to ask, what does the cloud provider actually handle, and what is left in your lap when disaster strikes? This is genuine board-level risk we're talking about here.
Moving right along to Section 2, Identity defense, the absolute first line of defense. Let's look at how your systems authenticate who is who, because there's a fundamental difference in how these two approach it. Azure goes global. They use Microsoft Entra ID, which is a globally distributed architecture with automatic failover built right in. Because it doesn't just rely on a single region, a regional outage rarely takes down your authentication. AWS, on the other hand, takes a localized approach. They use Identity and Access Management, or IAM, which is highly regionalized. Now, AWS's approach is fantastic for reducing the blast radius if you use a multi-account strategy, but honestly, it definitely introduces more operational complexity compared to Azure's seamless global setup.
So for this round, looking strictly at identity resiliency, Azure takes the win. Entra ID's globally distributed architecture is just stronger and provides a much more seamless failover experience. It's honestly one of Microsoft's most resilient services.
All right, Section 3, Control Plane Isolation. This is a fascinating area that gets ignored way too often. Think of the control plane as the administrative brain of your cloud environment. Now, Azure has some historical control plane dependencies, specifically the Azure Resource Manager, or ARM. If ARM goes down, it can cause a domino effect, literally halting new deployments across multiple services, even if your existing stuff is still running. AWS takes a totally different route. They've aggressively regionalized their control planes. Services like EC2 and VPC APIs are locked down locally. So if a failure hits one region, it is tightly isolated there, like bulkheads in a ship, meaning it's way less likely to take down your global operations.
Because of that architecture, the winner here is absolutely AWS. Their setup inherently provides a significantly reduced blast radius, giving you much stronger isolation when the platform itself has a hiccup. Next up, Section 4, Infrastructure and Storage. Let's talk about the real heavy lifters of the cloud. For global networking and compute failover, Azure relies heavily on virtual WAN and paired regions. It's a highly capable system, for sure. But AWS actually pioneered the whole concept of availability zones in the first place. Plus, they utilize Transit Gateway and Cloud WAN for their global networking. Because they've been doing this so long, their ecosystem maturity and widespread adoption give AWS a slight edge when it comes to routing really complex infrastructure.
Now, 11. That is a really important number here. It stands for 11 nines of durability. Both Azure and AWS offer exactly 11 nines of durability for their primary storage services. So if we're just talking about raw storage resiliency and ensuring your data doesn't just vanish, it's literally a dead tie. Both providers are exceptionally bulletproof here.
Okay, Section 5, Cyber Recovery. This is the stuff that keeps CISOs awake at night.
We're talking about surviving ransomware and insider threats. To build a truly strong cyber recovery posture in Azure, it's kind of like a puzzle. You generally have to piece together a few things: integrating the Microsoft Defender suite, configuring immutable storage, and very often bringing in third-party recovery vaults to complete the picture. AWS takes a totally different path, with some incredibly strong native tools. They give you built-in vault lock, distinct cross-account isolation using elastic disaster recovery, and this is huge, remarkably strong hardware-level isolation through their nitrous system, which severely shrinks the hypervisor attack surface.
Because of those highly isolated baked-in tools, the cyber recovery winner is AWS. Having superior cross-account recovery and native hardware-level isolation just gives an enterprise much stronger out-of-the-box resilience against ransomware. Finally, Section 6, the decision framework. Let's zoom back out to the 30,000-foot view.
If we break down the requirements, it becomes pretty clear when you should strategically choose one provider over the other. If your company's heavily Microsoft-centric, like if Microsoft 365 and hybrid Windows environments run the show, and you really prioritize global identity resiliency and operational simplicity, then Azure is undoubtedly your go-to. But if you're building a cloud-native architecture from scratch, and your biggest priorities are maximum control plane resiliency, advanced cyber recovery, and mature multi-account disaster recovery, then AWS is the platform you want to rely on.
Actually, wait, let me pause right here, because this might be the most absolutely crucial takeaway from our source material today. The strongest architecture, it isn't Azure only, and it isn't AWS only. For massive Fortune 500 organizations, putting all your eggs in one basket and relying entirely on a single cloud provider is in and of itself a critical vulnerability. So what does the ultimate enterprise solution actually look like? Well, you have to build it layer by layer. It demands a multi-region and multi-account setup to naturally quarantine failures. It requires zero-trust identity for absolute access control. You absolutely need a mutable backup so your recovery data can't get encrypted by ransomware. And finally, cross-cloud disaster recovery. The whole shebang. True business continuity transcends any single cloud vendor.
There's a great quote from our sources. The organizations that survive major outages design for failure from day one. Tenant-level resiliency is, at its core, a business continuity strategy. You can't just build for the happy path. You have to architect your entire environment with the assumption that the underlying infrastructure is eventually going to break.
Which brings me to my final challenge for you today. Is your cloud environment truly designed to survive failure? Or are you just crossing your fingers and hoping for uptime? Because let me tell you, hope is not a strategy, especially when you're staring down ransomware or a massive regional outage. I highly encourage you to take this framework back to your teams and really critically examine your own disaster recovery assumptions. Thanks so much for joining me on this explainer, and keep building resilient systems.